Okay, we have our nice particle problem with the velocities and the accelerations right there. So there is all my work and answers for you to try this stuff on your own. But I have particle H and particle J going on here. I got a position of particle H and a velocity of particle J. So part A says find the velocity of particle H at t equals 1. So since they gave me the position, I just had to know my easy derivative right here to do the velocity. So take the derivative of that. You're going to go e to that power times by the derivative of that power, and then plug in the 1, and then you're done with part A. Find the velocity at that time. All right, then so part B, it says during what open intervals are the particles moving in opposite directions? So we know the particles, like if the velocities are positive, that means the particles are moving to the right. If the velocities are negative, the particles are moving to the left, right there. So we're kind of looking at where the velocities have opposite signs, and that's where they're going to move in opposite directions right there. So what I did, I took particle H and particle J. You're only on the interval between 0 and 5. So you don't care about going all the way to infinity. You're only going in between 0 and 5. So keep that in mind. This is the x prime. So this is the velocity of particle H. And to find I'm going to do a number line thing for both of these here. So I'm going to take the velocity and set that equal to 0. If you have e to a power, the e to the x graph, like e to the power graph, like that's not going to hit the x-axis there. So you're not going to get any zeros from that. So if you just set this portion equal to 0, that's going to get you t is equal to 2. And so what I did, I plugged that on a number line, and I'm doing test points on either side of it. So I took the 1 and 3 and I plugged it in here. And then like I did 2 times 1 minus 4 and 2 times 3 minus 4, like e to a power, that's going to be like positive above the x-axis right there. But then we're going to plug in like 2 minus 4 is a negative number, and then 6 minus 4 is a positive number. So this means particle H, when the velocity is negative, the particle H is moving to the left between 0 and 2, and then between 2 and 5, because remember, the problem only exists between 0 and 5. That's all we're talking about. That's where the particle H is moving to the right. And then I did a similar thing for particle J. Particle J, they gave us this velocity for particle J. I didn't have to find that. They gave that to us. And then if you set that equal to 0, you get two critical numbers there. So I put those on my chart. And then you're only going between 0 and 5. So I didn't check anything to the left of that. So I just checked something in between there, like 1/2 and 2. And I plugged it in for the t's right there. And then I got a negative and a positive answer. So that means that tells us where particle J is moving to the left and between 0 and 1. And particle J, since the velocity is positive, is moving to the right between 1 and 5. So as I looked at those answers, this going left is between 0 and 2, going left between 0 and 1. So that means between 0 and 1, they're both going left. And this is going to the right between 2 and 5. This is going to the right between 1 and 5. So between 2 and 5, they're both going to the right. So on those intervals, since the velocities are the same sign, that's when we're going to go in the same direction. But be careful. It says when are the particles moving in opposite directions. And so if that's what your problem is in between 0 and 5. So if that's where you're going in the same direction, that means in between 1 and 2, that's where the velocities are going to have opposite signs. And so that's where H and J are going to be moving in opposite directions. So I just said, hey, it kind of helped me figure out where they're the same first. And then I said, okay, in between 0 and 5, those are already accounted for. So the only thing that's not accounted for is this guy. That's where they're going to be opposite directions right there. Like this one's going to the left, and then this one's going to the right. In between there. So just mention opposite directions, and then since the velocities have opposite signs right there. So practice that stuff on your own there and just play around with that. Make sure you can get that all by yourself from scratch. All right, now when it's asking, is the speed of the particle increasing, decreasing, or neither? Remember what you're looking at. You gotta look at the sign of the velocity and the acceleration. If speed is increasing, if velocity and acceleration have the same sign, speed is decreasing, if velocity and acceleration have opposite signs. So I didn't really need to do too much work here because it gave me the velocity of J equation. So I took 2 and I plugged it in for those T's right there, and I got a positive answer. So that told me the velocity was positive, and this is the V prime, which is we know is acceleration. And so they told me at particle J, the acceleration is also positive. So I figured out on my own the velocity was positive. They told me the V prime, which is the acceleration, is positive. So since velocity and acceleration have the same sign, that means that speed is increasing at t equals 2. So make sure you get that justification in there. And then when they give you this initial position, find the position, always take into account the initial position. So if I want to find the position at 2, so this is my notation for the position at 2. I'm going to start with what the position was at 0, and I'm going to integrate that velocity between 0 and 2. So when you integrate velocity between 0 and 2, that tells you how far you went between 0 and 2, and this is taking into account your initial position right there. So they gave us that was equal to 7. And in here, no calculator, you had a pretty easy integral right here. Just do a u du on that thing. There's nothing to balance because the squiggles out perfectly. And then you just get that u to the third. So integrate that. Remember, you could stop right here after you integrate. You could plug your t's back in there and use the 0 and the 2, or you can stop right here after you integrate and plug in the top minus the bottom, but use this to convert your t's to the u's right there. So plug in the 3, plug in the 4, and then if it helps you without the calculator, that's like 1/4 times u to the 4th. So you could pull that constant out and then just do 3 to the 4th minus -1 to the 4th. And I thought that was some pretty easy arithmetic right there. 88 over 4 is just 20 to get 27. But they did have on the rubric, if the arithmetic ever gets a little bit crazy, they accepted this answer right here. Okay, so just be a little bit careful with that. If you see something that you know how to do and you like kind of finishing that or just want to practice just in case, but sometimes when that arithmetic gets crazy, they will accept this particular answer right here. You got to have the proper notation. They said if you're missing a parentheses, then they're not going to give you credit for that. That you would have to go and get that 27 right there. So just make sure that notation is perfectly and you can read it and all that good stuff there. But if ever does look a little bit crazy, just leave that alone and you'll get full credit for that. Ingredients. Got to cook something, bake something, ingredients.